Here we go. More questions or probability questions answered. If two dice are tossed simultaneously, what is the probability that the number 4 will turn up with at least one die? So remember that two dice are tossed simultaneously. It was not explained what type of die, so we're going to, by default, we're going to understand that it is a normal die, a six-sided die. Okay, so a number 4 will turn up. Again, two dice are tossed simultaneously. So first we need to understand how many all of them are. Sorry. So in one die we have six sides. So we're talking about the cardinality or the number of elements or sample points in the sample space. So in the first die we have six parts, right? 1, 2, 3, 4, 5, 6. We're going to multiply that by the second die, which is also 6. So the cardinality of our sample space is 36 all in all. We're going to hold on that, and then we're going to make use of that in a while. Um, and then we want to understand the number of that 4 comes up. So we can do this analytically. So let's call the first die A, the second die B. So the probability of getting a 4 in A, I'll just call that 4A, 4 in A. Okay. So how many 4s are there in the first die? So there are 4 of them. So 4 over 6. Will not simplify that for now. And how many 4s are there in B? Okay. So we also have or rather, sorry. So there are 6 4s, not 4 over 6. Apologies. So there are 6 4s there in A. How many ways? 6 4s in A, all over 36 overall in the two dice. And we have 6 4s in B, all over 36. That's in the two dice. But notice that there is an intersection of 4A intersection 4B. This is the moment that there will be two 4s in both um, die. So if there are two 4s, there's only one intersection, which is 1 over 36. So applying the additive rule, which is the probability of 4A union 4B, this is equal to the probability of 4A plus the probability of 4B minus the probability of their intersection. So that will give us these numbers: 6 over 36 plus 6 over 36 minus 1 over 36, which is clearly going to give us 11 over 36. We cannot simplify that because it's a prime number. 11 is a prime number. So surely this is our answer. So this is how we do it analytically. We can also answer this in such a way which is we're going to use of symbols and images. Imagine when we throw 4s in the first die and we end up with 4. So what we have is 4, 1, that's one outcome in A. So let's call this in A. All the elements in 4A, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, and of course 4, 6. So those are the elements in 4A. How about the elements in 4B? Let's take a look at them. 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, and 6, 4. So notice this number here this one here. The 4 4 happens twice. So what we're gonna do is we're going to count them as one because it will be redundant. It will not be, the set will not be well ordered if we're going to count it twice. So if we're going to do this, we're going to count all of them. Let me use this one. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and of course 11. 4 4 will be counted as 1. So the answer here would be 11 all over the sample space, the totality of it, which is 11 over 36. And that jibes with our answer in the analytic case. Okay, so this is how we answer these kinds of solutions. There's also another solution wherein you're going to lay down all the possible pairs of the two dice, but that's kind of tedious to do. So I'll just show all the fours in this second method. So that's it for this video. I hope you learned something from here, and I'll see you in the next one. Thank you very much.